Now you're going to talk about dividing square roots. There are a few ways of doing it. First, I want you to check, are they perfect square roots? Okay, so A, 72 is not perfect. So then, can you divide them? So we have 72 divided by 2, and we get 36. So 36 is still inside the square root sign. 36 is perfect, so we get regular 6. If it wasn't perfect, that's when we would do the factor tree. On B, let's check number 1 again. Is 1 perfect? Square root of 1 is 1, and 121. That is also perfect, 11. So we're going to bring over this negative sign. Square root of 1 was 1, square root of 121 was 11. And this is our answer. We do nothing else to it, because we already took the square root of both signs. I noticed a lot of people, when they did this on their test, they put a square root sign on top of this. That is now wrong. Do not put a square root sign on top of it once you use it. Now C. Once again, we need to see if you can divide here. So we have 720 divided by 20. Once again, we just happen to get 36. So 36 is on the inside of the square root. We have not taken care of the square root yet. When you take the square root, you get 6. It was another perfect one. Now over here, are they both perfect? Yes, they are, because the square root of 144 is 12, and the square root of 196 is 14. So, and you really should simplify that, but I'm not going to make you on a test. So, but if we did, 2 goes into both of these, so if we divide both by 2, we get 6 over 7. So 6 over 7 is really what our final answer is. Now, these down here, once again, you can divide some of these. Sometimes you're still left with a square root sign on the bottom. So these we are going to rationalize. Okay? That means I need to take the bottom, or the denominator, and multiply the numerator and denominator by it. So if we come back over here, and you take the square root of 3. We're going to put it up top and on the bottom. So 5 is going to stay because there's no number out here. 6 times 3 is 18. On the bottom, 3 times 3 is 9. We have not gotten rid of any square roots yet. Square root of 9 is 3. We have 5 here. However, if you realize that 18 can be broken down, you need to do it. So 6 times 3, 6 is 2 times 3. There is a pair here that was hidden. So that 3 needs to now come on the outside, and that 2 stays on the inside. So 5 times 3 is 15, square root of 2, over 3. If we can reduce this, 15 divided by 3 is 5. So we need to do that, and then leave your square root of 2. So this is our final answer right here. Now, F. I'm going to take it in times with the square root of 21. So, we still have our negative. And then we've got 3 times the 21. So still have the negative up top. 3 times 21 is 63. It's still inside the square root sign. Now, remember over here we did 3 and square root of 3 times square root of 3 made square root of 9, and then just broke out and made a regular 3. We can do the same thing here. So square root of 21 and square root of 21 just makes regular 21. We need to break down our 63, which was 3 times 21, and 21 is 3 times 7. So we've got a pair of 3's. So negative 3 square root of 7 over 21. Check, can this be simplified, and it can. 3 goes into both. So we have negative 1 square root of 7 over 7. These two cannot be simplified because one is inside the square root sign and one is outside. So that is our answer. Okay, 2 more here. We have 2 square root of 6. So we are going to take top and bottom by whatever's in the bottom. So 3 times 2 is 6. 27 times 6 is 162, so it goes inside here. 2 times 2 is 4. Square root of 6 times square root of 6, it's just regular 6. Okay, 162, so kind of make a side note. We just did 27 and 6. So 6 is 2 and 3. 27 is 3 and 9 and 3 and 3 out of that 9. So we have a pair of 3's here, a pair of 3's here, and single 2. So this 6 comes over right here, times a pair of 3's, times another pair of 3's, square root of 2. 4 times 6 is 24. 6 times 3 is 18 times 3. So all of this here was 54. See if you can simplify this right here. Okay. Let's see, I know 6 goes into both. But so 6 goes into 54 9 times. Square root of 2. 6 goes into 24 4 times. 9 and 4 cannot be simplified anymore. So that is our answer right there. H. Multiply by the denominator again. So we've got 4 square root 32 times 5. 32 times 5 is 160. Square root of 5 times square root of 5 is regular 5. If we can do 160 in the factor tree, we need to. That is 16 times 10, which is 4 and 4. So 2, 2, 2, 2. So pair of 2's, pair of 2's, 2 and 5. So single, single. So bring down that 4 times a pair of 2's times a pair of 2's, square root 2 times 5, because those are both singles, all over 5. So 4 times 2 is 8, times 2 is 16, square root 2 times 5 is 10, over 5. We can't simplify this, so we are done.